Section 4, Video 4. So let's apply what we know or have learned and do an actual coordinate proof. Now this one asks us to graph a midsegment, MN. But notice there is no MN on this graph. We have a point Z, we have a Y, and an X. And that's it. So what MN are they talking about? Well, they said that it will be a midsegment, which by definition we said a midsegment connects two midpoints of a triangle, and then it's parallel to the third side, and the length is half as much as the third side. Well, there is no midsegment on this picture, but they want us to draw one, and its endpoints will be MN. The clue is that it's parallel to XZ. Now XZ is right here, so the only line that we could draw parallel to that would be something like this. So that means we are going to make a midsegment that connects the midpoint of YZ and XY. So where would that be? Well, it's somewhere in the middle. Now one would guess here, and one would guess here as being the midpoints, but we can't guess, we have to show. All right, so let's find the midpoint. So MP from midpoint of YZ or ZY. So here's the formula. On the other page it was the sum of the two x's. So again, we are focusing on this segment, ZY. So I take the x of the z, I add it to the x of the y, and I divide by 2. Then I take the y of the z, or the first point, add it to the y of the other point, and divide by 2. And this is going to give me a coordinate. And we will get 4, 7. And we're going to call this, well, this doesn't matter, but we'll call this one M. It's M and N is what they want. So this is point M. Now does that work out? Over 4. Now this is the origin. So if we go over 4, 1, 2, 3, 4, and up 7, 6, 7, we get right where we want to be. So that verifies that that is the midpoint, and that's M. Now let's find the midpoint of XY. So now we're focusing on this side of the triangle. So let's take the first x, and we'll call this one the first one here. So we'll take the x of the first one, add it to the x of the second one, second point, divide by 2. Take the y of the first one, add it to the y of the second coordinate, divide by 2. And that will give us 3 and 3. And we will call that point N. So does that work? Well, 1, 2, 3, 1, 2, 3 puts us right on the point we thought was going to be the midpoint. And we are right. Now that is a coordinate proof showing us how we know that is the midpoint. So it's using a formula. Okay, so now we've done what they've asked for the first part. Now they ask us to verify that this segment meets the criteria of a midsegment. Now, as I mentioned earlier, I said that a midsegment is parallel to the opposite side. So let's do that first. So we're going to show, or try to show, and this is our new line now, MN, the segment. We're going to show that segment MN is parallel to segment XZ. Now, parallel involves slope. Now, you can calculate slope on a coordinate grid just by counting, or you can use the formula. And I don't care which one you use in this case when it comes to slope. For example, I can say from X to Z, I go up 1, 2, 3, 4, 5, 6, 7, 8, and over 2. 8 over 2 is the slope, and when I reduce it, sorry, that's a 2. 8 over 2, and when I reduce it, I get 4 over 1. That's the slope of that line by counting, and I will accept that in the homework and quizzes. But the slope formula is something we also want to be comfortable with because it's using coordinates. So let's do that. So I'm going to take the y of, I'm going to start with z. So I'm going to go the y of the first or second coordinate, depends on what order you want to do, as long as we're consistent. So 9 minus 1 over 3 minus 1. That's a difference in y's over difference in x. And we get 8 over 2, which is 4, or 4 over 1. And that's what we thought. Now let's find the slope of xz. Or that was slope of xz. So slope of mn would be, and we have the two coordinates right here. So I'll take 7 minus 3 as a change in y's, and 4 minus 3 as a change in x's, and we get 4 over 1, which is 4. The slopes are the same, therefore we can conclude that the two lines are parallel. And that is our first criteria that we're trying to show. So we've shown the two lines are parallel. Our last one is to show that the lengths have a certain relationship. And if you remember, we said that the length of the midsegment is half as big as the third side, so we have to double it. So we are talking about length. So that's where distance formula comes in. So we are trying to show that, and this is how I would write it, it's easier to double something than take the half of something sometimes. So I'm going to say that line MN, or segment MN, is equal to segment XZ. Now we know that's not true because the mid-segment is shorter. So I'm going to say that if you double the mid-segment, it'll be equal to the third side, XZ. So distance formula. So let's find the distance of XZ. So that formula is the two x's subtracted and squared, the two y's subtracted and squared, and then we root. And that will give us 2 squared plus 8 squared, all underneath the square root, which will give us 4 plus 64 underneath the square root, which gives us square root of 68, which is approximately 8.25. And that is the length of XZ. Now that's the longer of the two. Now let's find out the length of MN. So same idea. We take the coordinates. I want to go the x value, so 4 minus 3 squared, 7 minus 3 squared, that's a 7, square root, we get 1 squared plus 4 squared, square root, which is equal to 1 plus 16, square root 17, which is equal to 4.12. Now, is 1/2 of the other? It's very close, but it's not exactly half, and that's because of our rounding. Now, if you remember, there's one other way to do this when it comes to radicals. You can simplify a radical sometimes. So if we take this one, root 68, and simplify that, if we break that down, this is a way to simplify a radical. If I divide by 2, it's upside down division here, I get 34 If I divide that by 2, I get 17. And this is something we'll go over later in the quarter as well. But if there's a pair of anything, in this case there is a pair of 2's, it can come out of the radical, and on the inside you still have just the 17. Now if you look at it this way, 2 times root 17, and this one is root 17, then one is twice as big as the other. Now this is okay, but this is really the official representation of it. And that has verified the 2 criteria of a midsegment. Parallel to the third side and half as big as the third side. And this ends section 4, video 4.